Hello, everyone. Thank you so much for joining us today for our webinar titled Food Packaging Failure Analysis. This webinar will be hosted by my colleagues Trish Hook and Chris French. I'm Amy Knock, and I will be moderating the webinar today. That concludes my very brief introduction today. Trish, I will now pass the webinar off to you. You may begin your presentation.
Thank you so much, Amy. Hi, everybody. Thank you so much for taking the time today to join us for our Food Packaging Failure Analysis webinar. We are featuring our Eurofins SN Special Analysis West Lab in Tustin, California. Today, the webinar will be presented by Chris French, who is our lab director at SN, and myself, Trish Hook, Business Development Manager for the SFA group. So who are we? Eurofins SF Analytical is a cluster within the Eurofins network, and our cluster includes the following labs: SF Analytical, GMP Microbiology, Animal Health Craft, and SN Special Analysis West. How do we differ from the rest of the Eurofins locations? Our group brings a think outside the box approach and expert understanding to complexities involved in unique investigative projects, covering categories from food and beverage, medical, aerospace, cosmetics, packaging, and much, much more. As you can see from this map, this shows how our group covers North America from Wisconsin to Pennsylvania to Indiana, North Carolina, and of course here today in Tustin, California. I'm now going to hand it over to Chris French, who's going to tell you a little bit more about SN Labs.
Thanks, Trish, and thanks again to everyone here today for carving out some time to learn a bit about packaging failure analysis. I'm Chris French, Technical Director for Eurofins SNN Special Analysis West here in Tustin, California. For those of you who are not local, that's about 10 minutes south of Disneyland here in Southern California. As part of the greater Eurofins network, our lab is really unique because our specialty is investigative and forensic testing. At traditional labs, clients will submit samples and receive a fairly generic test report. But here at SNN, we work collaboratively with clients to understand the background and details of complex materials or contamination issues. So in today's presentation, I'll provide everyone with a high-level overview of our offerings. Then Trish and I will move fairly quickly through several case studies in which we've helped our clients solve some real-world packaging issues. Go ahead. In terms of the methods and services we provide, we have state-of-the-art facility here in Tustin with capabilities in spectroscopy, chromatography, and microanalysis that we use to solve issues, including packaging failure analysis, foreign material identifications, and custom investigations, including litigation support. Next slide. Just as a high-level overview before we get into the packaging piece, some of the other offerings that we offer here in Tustin, in addition to failure analysis, we have an electron microscope for high magnification imaging. We've worked on off odor, off flavor for foods and also packaging. Foreign material characterization, drug identification is one of our core competencies, but also we do medical device extractables, which is fairly unique, and then additional techniques such as particle size distributions. And very importantly, we can take our data and help you with legal or insurance cases by going into court or providing depositions. Legally defensible reports is what we do. Go ahead, Trish. In terms of packaging specifically, we've worked on a wide variety of packaging types over the past few decades, including aluminum beverage cans, plastic bottles, vacuum seal bags, pouches, food wraps, paper and cardboard, and even single-use coffee brewers. So when a packaging failure analysis job comes in, each project is pretty different, but there are a couple of things that we always do. The first thing what we do is we take a lot of pictures, right? We do photo documentation to log the samples in. We take pictures at each step. And most importantly, we maintain a rigorous chain of custody should any of the investigations end up in court. We usually start out a packaging failure analysis with visual and low magnification inspections. What does the can or bottle look like from the inside and the outside, lot numbers, etc. But how we approach it really depends on what we suspect is the failure mode. And so the actual approach will vary from case to case, but again, the bottom line, all issues are documented with findings, photo documentation, comparisons to other products, etc. And at the end of the day, what you'll receive from SNN is a final report. Usually fairly extensive because we include all the data, imagery, spectra, reference spectra, details about the methods and equipment we use, and then, but what we try to do foremost is to provide just a 1 to 2 page summary report in plain English that anyone can understand. It's like, okay, this is what we saw. This is the failure modes that we observed. This is the likely root cause. And again, that's summarized in usually 1 to 2 pages in clear English. Next. We have a state-of-the-art laboratory that includes some of the most sensitive modern equipment available on the planet. We use infrared spectroscopy to identify materials. Again, we have an electron microscope, which is good for high mag imaging, and also elemental spectroscopy. We have a wide variety of chromatography equipment, and then a state-of-the-art 3D digital optical microscope, which is very nice for photo documentation of small particles. Next. So let's jump into the case studies. The first case study, a client came to us trying to understand why their beverage cans were leaking. It's basically an alcohol-based beverage, and you could obviously tell they had some issues because the cans came deflated with residues around the bottom, etc. One of the first things that we always do with an aluminum can is figure out what the inner liner is made out of. Some people may not even realize that all of the aluminum beverage cans have a plastic coating on the inside, and it's there to protect the inner diameter of the aluminum from the formulation. So the first thing we do is use infrared spectroscopy to identify that material. In this particular case, it was an epoxy resin. Most aluminum beverage can manufacturers have tended to move toward a BPA non-intent because of fear of health concerns surrounding BPA from epoxies. But then we'll take the can apart, as you can see in the lower right, and use a special pinhole leak detector. And that helps us to narrow down, okay, where did the failure occur? So this particular device will beep once it gets on a pinhole or a liner perforation and tells us where to look. So then once we know where to look, we'll use optical microscopy at fairly high magnification, take some pictures, and then we'll cut out that piece and put it in our scanning electron microscope, and then acquire elemental maps of the defect areas to really get down to the root cause. Next slide. So in this particular case, what we noticed right away on the ID of the can were blisters. It looks like there might be some foreign material debris stuck to the surface, but in reality, in this particular case, the liner was blistering. So basically gas was evolving under the liner, pushing up the can liner, and eventually a perforation occurred there. So our next job is to figure out why. So we put the piece in the electron microscope with those blisters removed and did some elemental mapping. So in the lower right there, you can see how useful the electron microscope is to look and see, okay, what is there underneath the blisters in, 2 dimensions at least, so that we can understand what particular elements are in what particular locations. In this case, we've seen patches of chloride salts and particles of a manganese iron alloy, and they were found in the corroded areas. Now we know chloride salts aggressively attack aluminum, so that's root cause number 1. And transition metal particles can also result in galvanic corrosion. That's basically an electric circuit that will chew away at the aluminum. But the interesting part was that all this debris was found between the ID liner and the aluminum wall. So that implies that poor environmental controls or poor washing or surface prep of the aluminum inner surface before the liner was applied is the root cause. And so that's helpful because they can go back to the supplier and say, okay, the surface wasn't properly, prepared before the liner was applied. And so that, they can just issue a scar and basically be done with it on their side. Next slide. The second case study is a commercial bottler who came to us. It was like, okay, our water bottles have these black specks. What is that? So what we've done in this particular case is simply cut out the polymer that's affected, cut down to the black speck, take a tungsten microprobe, pull a little bit out of that, and then run infrared spectroscopy. And in this particular case, the infrared spectrum was fairly definitive in terms of showing that the inclusions were cardboard. So they had an environmental problem here. Apparently some cardboard bits got into the hopper or whatever. And then, during the blowing process, the material basically burned and turned black. Next slide. In this case, we had a medical device manufacturer looking for a very specific failure mode, and that is when a needle is pushed through the septum of an IV bag, does it create particles of the septum that could, potentially flow into a patient? So in this case, just as an example of something we can do in terms of support for 510K submissions to the FDA, etc., we filtered the contents of the bag, looked for particles that appeared to be the septum material, and used EDX and infrared spectroscopy to identify, and then provided the client with absolute counts of particles that resulted from that needle coring. Next slide. We also had a manufacturer of cannabis pouches experiencing delamination of layers. Some people don't realize that what looks like a plain pouch may be 5 to 7 different layers. So the analysis can get fairly complex fairly quickly. So what we started out with is identifying layers, as you can see in the upper right, multiple layers with multiple different polymers. And we used infrared spectroscopy to identify those polymers. And then what we did was to look where the delamination was and inspect for slippery surface residues. In this particular case, what we found in the heavily delaminated areas was residues of mold release agents, such as that fatty amide there that you can see in the lower right-hand corner. So basically the failure to clean the polymer or overuse of the mold release agent was their particular root cause. So on that note, I'm going to pass it back to Trish, who's going to take you through some additional case studies.
Thank you, Chris, so much for those great examples. Love seeing those. I'm going to talk through some additional issues that might not be an obvious consideration when it comes to failure. such as degradation of packaging during storage, if it's been affected by heat or light, transportation conditions, if the shipments travel through hot or cold climates, altitudes, or improper production procedures. So these are some things you might not even consider would affect your packaging. So some examples would include this case study here, which is an off flavor, and the customer observed off flavor and color in the prepackaged food product. We did a controlled approach of a testing using GCMS, and the conclusion was there were significant levels of caprolactam, which is a component of the ink that was used on the surface of the inside of the lids. Therefore, when we went back to the manufacturer, they confirmed that the lids were stacked during the process, allowing for the transfer of the ink into the product. So now they know the issue and they can resolve the manufacturing process so that doesn't happen again. In this case study, client received complaints from consumers that there was gas production and foaming when they opened the bottles. For this approach, we used a microscopic examination, subculturing of product samples to recover organisms, and the conclusion was that there was a spoilage yeast which should have been addressed by tunnel pasteurization. After reviewing batching records and found delays of several days between batching. Therefore, this helped the client work with the co-packer to set up better guardrails for procedures moving forward. And lastly, this case study, again, another microbial issue. Over a 4-month period, there was color changes, for example, turning red to yellow, purple turned blue in all of their drinks. Again, we did the microscopic examination and subculturing of organisms, and we identified the lactobacillus paracasei was caused due to a contamination between the pasteurization whole tube and filler. This meant that their routine APC testing only was not sufficient enough as a monitoring approach, and they corrected it for future production. While we're on the subject of color changes, actually, we wanted to share with you that we have advanced our colorimetry capabilities that can detect even the most subtle color changes in your products or even packaging label. As you can see here, we use an LAB absolute color approach, which eliminates the guesswork from direct color comparisons. Finally, I wanted to show some additional packaging testing services we also offer, such as leak tests or seam integrity, regulatory compliance, that's global, from FDA to EU to South America and Asia, much more. Custom migration for projects such as FCNs, and finally, shelf life and stability studies. Today's takeaways are food packaging failure analysis and various approaches, additional packaging issues to consider, additional food packaging testing capabilities, and much more. Thank you so much for joining us today. We really look forward to helping you in the future. Here's how you can get a hold of us. We look forward to hearing from you soon. Thank you.
Thank you so much, Trish and Chris, for the presentation today. Now we will move into a few commonly asked questions. So the first question that I have here to ask is, in Eurofins' experience, what are the most common packaging failure analysis types?
I think by far the most common inquiry we see are leaking aluminum cans. There's just so many ways that things can go wrong with an aluminum can. Most often we see corrosion. The client sometimes thinks, oh, our formulation is just too aggressive, but in reality, as I showed in one of the case studies, we have, pinhole leaks that come from, things like the inclusions that I demonstrated. And also we see seams that don't meet specifications, et cetera, et cetera. So yeah, by far the aluminum cans are the biggest issues, although we do see a lot of inquiries for things like off color, off odor, can bottle bloating, where the packaging is deformed or just simply not conforming to specifications and are in need of investigation to find the root cause of that failure.
Great, thank you for that, Chris. The next question here is, what is the most challenging package failure type in Eurofins experience that we've seen?
Yeah, I showed one of my case studies where we get something that looks as simple as a pouch, but in reality, you start to pull it apart and suddenly you're looking at seven different layers or so, and you're looking for a failure not just in one particular layer, but it could be any of those layers. And so, we have to tease those apart, identify the layers with infrared or Raman or EDX spectroscopies, and then there's also adhesives or barrier layers that can be in between those layers of polymer or even metal films. But it takes quite a while to sort all that out, and it can be tedious or challenging, but we have a pretty tremendous track record of success just because we have very highly skilled analysts here at Eurofins and state-of-the-art instruments like the electron microscopy, infrared microscopy, and also just advanced analytical techniques of all kinds.
Wonderful. Okay, that's very, very helpful. That wraps up today's session for us. And I want to thank you again, Trish and Chris, for your expertise and presentation. And thanks again, everyone, for attending.
Thanks, everybody.